All right, so I hope you're doing well, Naja. So what I'm about to do is explain the new concept that we're learning in class. So we're on Delta-Wye circuits. So a Delta-Wye circuit is not a series and parallel combination. For a delta circuit, as you can see, you should have a triangle in your circuit, which looks like a delta. For a Y circuit, you have a Y in your circuit. Now, in order to solve these questions, we have to change a delta into a Y. And we have to change a Y into a delta. And when we do this, we will be able to solve the circuit in a series parallel combination. So it's now not a series parallel combination, but when we transform it, it'll become a series parallel combination. The first one I'm going to go over is how to change a delta circuit into a Y circuit, and there's multiple steps. The first step you want to do is label your corners of the delta. So this is going to be delta to Y. Step 1, label delta corners. That's 1, 2, 3. I already labeled this one for you. It doesn't matter how you label it, as long as you label them 1, 2, and 3. The second step you want to do is to label the resistors along the delta. So label your delta resistors. So the way we're going to do this is the resistors on the delta will be named after the opposite corner. So since this is corner 3, this will be R3. Since this is corner 2, this will be R2. And since this is corner 1, right here, this will be R1. Now the third step is to draw a Y in the delta and label your Y resistors. So the way we do this, I'm going to use a different color. I like to draw a dot in the middle, and from each corner, I like to connect them to the dot. And the way we're going to label each of these resistors is by looking at the two resistors that it's in between from the delta. So since this one is in between R2 and R3, this is going to be called R23. Since this one is between R1 and R2, this is going to be called R12. And since this is between R1 and R3, this will be called R13. All right. Now, step 4 would be to calculate R12, R23, and R13. Because we just drew these resistors so we don't know what they are. Luckily, in class, I gave everyone an equation sheet. And you can find this equation sheet online. So, you're going to use these equations when you're doing a delta to a Y. You're going to use these three, and I'm going to post another video when we go from a Y to a delta. So to recap so far, we labeled our corners 1, 2, and 3. Then we labeled our delta resistors based on the opposite corner. So opposite R1, opposite R3, opposite R2. Then we drew our Y in with the resistors, and we labeled our Y resistors R23, R12, and R13. Now we have to calculate what those are. So looking at this equation, we have, it's going to be, for these ones, R12, R23, and R13, it's going to be this equation. And as you can see, if we're looking for R12, it's going to be R1 times R2 divided by the sum. For R23, it's going to be R2 times R3 divided by the sum. And likewise for this one. So first, since we already know what R1, R2, and R3 are, we can just add those into the chart. So R1 is 45, R2 is 30, and R3 is 30. So R12 will be equal to 45 times 30 divided by the sums, 45 plus 30 plus 30. And that's going to give me let me calculate the denominator first because that'll be the same for all of them. $105. And then 45 times 30 is $13.50. Calculating that, we get $12.86. Now for R23, we're going to do R2, which was 30, times R3, which is 30. So 30 times 30 divided by 105. That's going to give me 8.56. And now I'm going to do R13, which is R1, which is 45, times R3, which is 30, divided by 105, which should be the same as this, 12.86, because that's 45 times 30 divided by the denominator. All right, so now we can add those to our chart. We know this is 12.86. This is 8.56. And this is 12.86. Now, our fifth step will be to redraw our circuit deleting the delta part. So now we're going to redraw the circuit, but we're going to get rid of this line, and this line. Any line that is part of our delta. So when I do that, I'm going to have my battery. This is going to be corner 1. That's going to be the first branch of my Y. And I have this part of my Y. Then, this is the other part of my Y. There was supposed to be a resistor right here from that resistor right there. And then, there we go. Now this is a series parallel combination. And I can label this. This is R23, which was this resistor right here. This was R12. This was R13. And we can just label this any one we want. I'll just call this R4. I'll call this R5. Now, if you notice, we can simplify this. So we would do this like any other problem. These two are in series with each other, because if you look closely, these are along the same wire. These ones are also in series with each other, because if you look, those are along the same wire. So we can redraw this as but before I continue, note these are in series, but they're in parallel with each other. So this is R23 right here. What this is R12 added to 4, and this is R13 added to 5. So remember, R23 from up here was 8.56. Right here, this is R12 and R4. So R12 was 12.86. So 12.86 plus R4, which was 5. And remember, I add those normally because they're in series. So 12.86 plus 5 is 17.86. So that's what R12 is. R13 would be, R135 would be R13, which is the same as R31, 12.86 plus R5, which was 25. And I get 37.86. Now, after this, you would just solve it like a normal problem. So I can rewrite this circuit like where this part is just these combined. And if you notice, these are in parallel with each other. So since these are in parallel with each other, we do 1 divided by 1 over 17.86 plus 1 divided by 37.86. And this one would be the same, which is 8.56. So 1 divided by 17.86 plus 1 divided by 37.86. 1 divided by that answer would give me 12.13. And if I add 12.13 plus 8.56, I'll find my equivalent resistance. My equivalent resistance would be equal to, like I said, 8.56 plus 12.13, which gives me 20.69. So I can write this up here. And then if I want to find my total current, that's just going to be the voltage of that battery, which is 40, divided by the equivalent resistance, 20.69. So 40 divided by that gives me 1.92 amps. All right, so that's how we solve a delta circuit to a Y circuit. And in the next video, I'm going to show you how to go from a Y circuit to a delta circuit. All right, now we're back and we're going to be talking about how to go from a Y circuit to a delta circuit. And the first step when we do this type of problem is to draw a delta around the Y. By doing that, you're supposed to draw a delta around the Y. Now, the second step will be to label your delta and Y resistor. So remember, to label delta resistors, you have to look at the opposite corner. So that since this is corner 2, this will be R2. Since this is corner 1, this will be R1. And since this is corner 3, this will be R3. Now, let's label our Y resistors, which are these 3. Now, since this one is in between R2 and R3, this will be R23. And remember, R23 is the same as R32. Since this one is between R1 and R2, this will be R12. But since this is between R1 and R3, this will be R13. Now, we can add some of these values in our chart. I know what R23 is. I know what R12 is. And I know what R13 is, because it gave us our Y resistors originally. So in R23, I can write 15. In R13, I can write 30. And then in R12, I can write 20. Now, the third step will be to calculate R1, R2, and R3. All right, remember, up here we had to calculate R1, 2, R2, 3, and R1, 3. Right here, we just have to calculate R1, R2, and R3. Just like, remember, for a Y to a delta, we calculate R1, R2, R3. This is a Y to a delta, so we calculate R1, R2, R3. So, R1, this equation is a little bit more complicated, but look at and notice that these numerators are the exact same thing. So it's going to be R12 times R13. R12 times R13 is 20 times 30. Plus R13 times R23, which is 30 times 15. Plus R23 times R12. So R23 times R12 is 15 times 20. And note that since this is R1, the denominator is going to be the resistors that don't have 1 in there. So that will be R23, which will be 15. Calculating this numerator really quickly, we get 1350 divided by 15, which is 90. Likewise for R2, remember the numerator is the same, so it's 1350 divided by R13, which is 30. And then R3 is equal to 1350 divided by R12, which is 20. $45, and then this one's gonna be, so that's R1, R2, R3. We can add those into our chart. R1 was 90, R2 was 45, and R3 was 67.5. Now, what I'm gonna do is redraw this circuit, but now what I'm gonna do is delete the Y part. Up here, remember, I deleted the delta part. But for this one, I delete the Y part and keep the new delta that I had drawn.